Hello students, hope you are doing well. In this video we are going to discuss using a modular approach to network design 1 for the subject Enterprise Network Design of B7 semester IT, University of Mumbai. The topic using a modular approach to network design is divided into part 1 and part 2. We will cover in this particular lecture evaluation of enterprise network, Cisco SONA framework, functional areas of Cisco Enterprise architecture, guidelines for creating an enterprise network, enterprise campus module, campus infrastructure module, building access layer, building distribution layer, campus core layer, server farm module, and enterprise campus guideline. All these things consist of several diagrams. So be aware of these diagrams, and on the basis of these diagrams, you can write any answer related with these questions. Evaluation of enterprise network. You do not have to go for back in history to find time when networks were primarily used for file and print services. These networks were isolated LANs that were built throughout the enterprise or organization. As organization interconnected these isolated LANs and their functions grew from file and print services to include critical application, the critical nature and complexity of enterprise network also grew. Cisco introduced the hierarchical model to divide the enterprise network design separately for both campus and wide area networks into the access, distribution, and core layer. The solution has several weaknesses, especially for large networks which are difficult to implement, manage, and particularly troubleshoot. Network became complex and it was difficult to evaluate network solution end to end through the network. The hierarchical model does not scale well to these large networks. So here you can see in this mind map what portion we are talking about is given here. Okay. An efficient method for solving and scaling a complex task is to break it into smaller and more specialized tasks. Network can easily be broken down smaller because they have natural, physical, logical, and functional boundaries. Okay, so these are the functional boundaries. If they are sufficiently large to require additional design or operational separation, these functional modules can then be designed hierarchically with access, distribution, and core layers. The Cisco Enterprise architecture does just it reduces the enterprise network into further physical, logical, and functional boundaries to scale the hierarchical model. Now, rather than designing networks using only the hierarchical model, networks can be designed using Cisco Enterprise architecture with hierarchy, access, core, and distribution layer included in the version various modules as required. Designing with Cisco Core Enterprise architecture is not much different from what already used in practice. It formalizes current practice. There have always been separate hierarchies for the campus with access, distribution, and core. And for wide area network, the remote office was access layer, the regional office provided distribution layer, and the headquarter was the core. The hierarchies tied together at the campus backbone. So here you can see both campus and WAN it is derived for. Okay. The Cisco Enterprise architecture extends the concept of hierarchy from original two module campus and WAN. This is for campus and WAN both. This diagram is very familiar with Cisco SONA framework. The Cisco SONA framework provides an enterprise-wide framework that integrates the entire network, campus, branch, data center, enterprise, edge, WAN and MAN, teleworker, offering staff secure access to the tools, processes, and services they require. The module of Cisco Enterprise architecture represents focused view of each of the places in the network described in the SONA framework. Each module has distinct network infrastructure and distinct services. Network application extends between the module. So here different layers are shown. So on the basis of these layers, we categorize the services associated with these layers. Functional areas of Cisco Enterprise architecture. At the first layer of modularity in the Cisco Enterprise architecture, the entire network is divided into functional components, functional areas that certain network modules, while still maintaining the hierarchical concept of core, distribution, and access layer within the network module needed. The access, distribution, and core layers can appear in any functional area or module at the Cisco Enterprise architecture. The Cisco Enterprise architecture comprises of enterprise campus, enterprise edge, service provider, branch, enterprise branches, enterprise data center, and enterprise teleworkers. So this is the diagram of Cisco Enterprise architecture. Here you can see that enterprise edge, service provider, and server farm data center, campus core, building distribution, enterprise campus. These are the different modules which we can use here. Enterprise teleworker is also there, enterprise data center and enterprise branches are also there. So the dark shaded shows the module or functional areas associated with Cisco Enterprise architecture. The Cisco Enterprise Campus architecture combines a core infrastructure, intelligent switching, and routing with tightly integrated productivity, enhanced technologies including Cisco Unified Communication Mobility and advanced security. The architecture provides the enterprise with high availability through the resilient multi-layer design, redundant hardware and software features, and automatic procedures for reconfiguring network paths when failure occurs. IP multicast capabilities provide optimized bandwidth consumption and quality of services features ensures that the real-time traffic such as voice data or video is not dropped or delayed. Integrated security protects again mitigates the impact of worms, viruses, and other attacks on the network, including at the switch port layer. For example, Cisco Enterprise-wide architecture extends support for security standards such as 802.1x port-based network access control standard and the extensible authentication protocol. It also provides flexibility to add internet protocol, that is IP security and MPLS, VPN, identity and access management, and virtual LANs to compartmentalize access. These features help improve performance and security while decreasing costs. The Cisco Enterprise Edge architecture offers connectivity to voice, video, and data services outside the enterprise. The module enables the enterprise to use internet and partner resources and provide resources for the customer. Quality of services, service levels, and security are the main issues in the enterprise age. Now come to the Cisco Enterprise MAN and WAN and site-to-site VPN module. It is a part of the enterprise edge. It offers convergence of voice, video, and data services over a single Cisco Unified Communication Network, which enables the enterprise to span large geographic areas in a cost-effective manner. Quality of services, granular services level, and comprehensive encryption option helps ensure that secure delivery of high quality corporate voice, video, and data resources to all corporate sites, enabling staff to work productively and efficiently wherever they are located. Security is provided with the multi-service VPNs, both IP security and MPLS, over layer 2 or layer 3 WAN, hub and spoke or full mesh topology. The Cisco Enterprise data center architecture is cohesive, adaptive network architecture that supports requirement for consolidation, business continuance, and security while enabling emerging service-oriented architecture, virtualization, and on-demand computing. Staff, suppliers, and customers can be provided with secure access to application and resource, simplifying the streamlining management and significantly reducing overhead. Redundant data centers provide backup using synchronous and asynchronous data application and replication. The network and devices offer server and application load balancing to maximize performance. This architecture allows the enterprise to scale without major changes in to the infrastructure. These modules can be located either at the campus as a server farm or remote facility. The Cisco Enterprise Branch architecture allows enterprise to extend head office applications and services such as security, Cisco Unified Communication, and advanced application performance to thousands of remote locations and users or to a small group branches. Cisco integrates security, switching, network analysis, caching, and converged voice and video services into a series of integrated service routers (ISR) in the branch so that the enterprise can deploy new services without buying new routers. This architecture provides secure access to voice, mission critical data, and video applications anywhere, anytime. Advanced routing, VPNs, redundant WAN links, application content, caching, and local IP telephony call processing features are available with high level of resilience for the branch offices and optimized network leverage the WAN and LAN to reduce traffic and save bandwidth and operational expense. The enterprise can easily support branch offices with the capability to centrally configure, monitor, and manage devices located at remote site, including tools such as Cisco AutoQoS and Cisco Router and Security Device Manager, graphical user interface, quality of service wizard with proactively resolve congestion and bandwidth issue before they affect network performance. Now come to Cisco Teleworker, Enterprise Teleworker. This architecture allows enterprise to securely deliver voice and data service to remote small or home offices known as small office, home office, SOHO, over a standard bandwidth access service, providing a business resilience solution for the enterprise and a flexible work environment for employees. Centralized management minimizes the IT support costs and robust integrated services mitigates the unique security challenges of this environment. Integrated security and identity-based networking services enables the enterprise to extend campus security policies to the teleworker. Staffs can securely log in into network over always on VPN and gain access to authorized application and services from a single cost effective platform. Productivity can further be enhanced by adding IP phone, thereby providing cost-effective access to centralized IP communication system with voice and unified messaging services. This architecture also allows network designers to focus on only a selected module and its functions. Designers can describe each network application and services on a per module basis and validate each of Each part of complete enterprise network design modules can be added to achieve scalability if necessary. For example, an organization can add more enterprise campus module if it has more than one campuses. So this is all about functional areas of the Cisco Enterprise architecture. Guidelines for creating an enterprise network. This figure shows sample network divided into functional areas, whatever discussed in previous slide. Enterprise campus, campus backbone, internet, MPLS, universal gateway, PSTN network, telecommuter, branch offices, teleworker home PC. So these dark shaded shows the different modules, and this whole thing is enterprise campus. So when creating an enterprise network, divide the network into appropriate areas, where enterprise campus includes all devices and connections within the main campus location. The enterprise edge covers all communication with remote location and the internet from the perspective of enterprise campus. And the remote modules include the remote branches, teleworkers, and remote data centers. Define clear boundaries between each of the areas. So depending on the network, an enterprise can have multiple campus location. A location that might be a remote branch from perspective of central campus location might locally use the Cisco Enterprise Campus architecture. Enterprise Campus Module. So Enterprise Campus Module, it is a site which is large site that is often the corporate headquarter or major office, regional office or SOHOs, and mobile workers might have to connect to the central campus for data and information. As shown in this figure, the enterprise campus functional area includes campus infrastructure module and typically a server farm module. So here you can see the server farm and the campus infrastructure, which includes building access, building distribution, campus core. There are multi-layer switches. These are multi-layer switches associated with this building distribution and campus core module, while and they are interconnected thoroughly. Then it is layer 2 switches connected in building access layer, and the output is going to enterprise edge module, and yes, to enterprise edge module. So in this campus infrastructure module, design consists of several buildings connected across a campus core. The campus infrastructure module connects devices within a campus to server farm and enterprise edge module. The single building in a campus infrastructure design contains a building access layer and building distribution layer. When more buildings are added to the campus infrastructure, a backbone or campus core layer is added between buildings. The campus infrastructure module includes three layers. These three layers are building access layer, building distribution layer, and campus core layer. In the most general form, the building access layer uses labeled layer 2 switching. Okay, here layer 2 switching, it is not MPLS or multi-layer switch. And building distribution layer uses multi-layer switching. So what is inside building access layer? The building access layer located within campus building aggregates end user from different work groups and provides uplinks to the building distribution layer. It contains end user devices such as workstations, Cisco IP phones, and network printers connected to layer 2 access switches. Virtual LANs and STP might also be supported. The building access layer provides important services such as broadcast suppression, protocol filtering, network access, IP multicast, and quality of services for high availability. The access switches are dual attached to the distribution layer switches. The building access layer might also provide power over Ethernet (PoE) and auxiliary virtual LANs to support voice services. Now come to building distribution layer. So this is building distribution layer. Inside that building distribution layer, it aggregates the wiring closets within the building and provides connectivity to campus core layer. It provides aggregation of the access layer network using multi-layer switching. The building distribution layer performs routing, quality of services, and access control requests for data flow into the multi-layer switches and onwards into campus core layer. Response follows the reverse path. Redundancy and load balancing with building access and campus core layer are recommended. In this particular figure, the building distribution layer has two equal cost paths into campus core layer, into the campus core layer. Okay. In its routing table to every destination network, if one connection to the campus core layer fails, here you can see to enterprise edge module is twice. So if it is fails, all routes immediately switches over to the remaining path. Now come to campus core layer. This is the third layer, campus core layer. So what is inside that? The campus core layer is the core layer of campus infrastructure module within the enterprise campus functional area. The high performance switches backbone connects the building and various paths of the campus. Specifically, this layer interconnects the building distribution layer with the server farm and enterprise edge modules. Here you can see the campus core layer of the campus infrastructure module provides redundant and fast converging connectivity between building and with the server farm and the enterprise edge module. It routes and switches traffic as quickly as possible from one module to another. This module usually uses multi-layer switches for high throughput function with added routing, quality of services, and security features. Now come to next module, that is server farm. Server farm, here you can see why server farm is used and what is the responsibility of server farm. A high capacity centralized server farm module provides areas users with internal server resources. In addition, it typically supports network management services for the enterprise, including monitoring, logging, and troubleshooting the core common management features from end to end. The server farm module typically contains internal email and other corporate servers that provide internal users with application file, print, email, and domain name system. So in this particular figure, we can see because access to these server is vital as best practice, they are typically connected to two different switches to enable full redundancy or local sharing. Moreover, the server farm module switches are cross-connected with the campus core layer switches, thereby enabling high reliability and availability of the servers in the server farm module. The network management system performs system logging, network monitoring, and general configuration management functions. For management purpose, an out-of-band network connection, a network on which no production traffic travels to all network component is recommended. For location where an out-of-band network is impossible because of geographic or system-related issue, the network management system uses production network. So, network management can provide configuration management for nearly all devices in the network using combination of some technologies. First technology is Cisco root. It can act as terminal servers to provide a dedicated management network segment to console ports on Cisco devices throughout the enterprise by using reverse telnet functions. Next is More extensive management features like software changes, content updates, log and alarm aggregation, and simple network management protocol SNMP can be provided through the dedicated out-of-band network management segment. Enterprise Campus Guideline. Follow these guidelines for creating the modules within the Enterprise Campus functional area. Initially, we start with step 1. Select module within the campus that act as building with access and distribution layer. Next module determines the location and the number of access switches and their uplinks to distribution layer switches. Third step is select the appropriate distribution layer switches taking into account the number of access layers, switches and end users. Use the at least two distribution layer switches for redundancy. Step 4. Consider two uplink connections from each access layer switches to the two distribution layer switches. Step 5. Determine where servers are or will be located and design the server farm module with at least two distribution layer switches that connects all servers for full redundancy. Include out-of-band network management connection to all critical devices in the campus network. Step 6. Design the campus infrastructure module campus core layer using at least two switches and provide for expected traffic volume between modules. And finally, interconnect all modules of enterprise campus with the campus infrastructure modules campus core layer in the redundant manner. So these are the steps. Following these steps, we can design the enterprise campus. In this lecture, we have covered evaluation of enterprise network, Cisco SONA framework, functional areas of Cisco Enterprise architecture, guidelines for creating an enterprise network, enterprise campus modules, which includes campus infrastructure, building access layer, building distribution layer, campus core module, server farm module, and enterprise campus guidelines. In next video, we will see the using a modular approach to network design part 2. Thank you very much. Bye for now. Have a nice day.